Guys, we're dealing with non-homogeneous or inhomogeneous differential equations here. So DE, again, stands for differential equations with the S at the end of it, okay? So the equation here is y triple prime plus 3y double prime minus 10y prime equals to x minus 3. So this is our non-homogeneous equation with our source term on the other side of the equal sign, which is x minus 3, which is a polynomial of degree 1, okay? So now if you're solving for, at the end of the day, if you're solving for this equation, we need to have to add the solution from the homogeneous equation and the solution from the particular solution. So those two added together gives you your final answer. So let's go at it. First thing we got to do here is first step is change this equation into a homogeneous equation. So homogeneous equation, that will give us what? Y triple prime plus 3y double prime minus 10y prime then equals to 0. So we make this one equals to 0, right? And this will be our homogeneous equation. So we know our homogeneous equation, so the next step now is to do our characteristic equation. So that's the second step. So characteristic equation, which is going to be then k power 3 plus 3k squared minus 10k equals to 0. So we have this one here to solve for. So all the time you think about, can I factor it if that's possible? If I can't, what else way can I do it? Am I going to do long division? Am I going to do trials by errors? Anything like that will help. But you have to think very quickly, which is the easiest way for you to go. So now in this case, we have k that we can take out. So that's our common factor, right? So that gives a k squared plus 3k minus 10 equals to 0, okay? And then after that, inside the parentheses, we have a trinomial there with power 2 as the highest power. So the question is, can we factor that one with a trinomial here by the AC method? Meaning, do I have two numbers that multiply, give me negative 10, and then two numbers out of give me 3? It's 5 and negative 2. So that will give me what? K, then plus 5, and k minus 2. Because 5 times negative 2 is negative 10. 5 minus 2, which is positive 3. And you do, and then you're good. All right? Then we have our three factors here. So we have k equals to 0, first one. We have k equals to negative 5. Then we have k equals to a positive 2. Okay? So how do we then write our final answer for the homogeneous solution? That's why we have the y sub h here. So that would be c1 exponential 0x plus c2 exponential negative 5x plus c3 exponential 2x. Okay? So once we have that, so this one here, okay, 0x is 0, so exponential 0 is going to give us what? 1, correct? So we end up with c1 only plus c2 exponential negative 5x plus c3 exponential 2x. And then this is our y sub h here. Okay? So we're done with this. Now we got to go for the y particular solution. So to get to that part, so we need to have an approach, or we call it also the ansatz. So an approach. So the approach is going to come from your source term. So in this case, we have a polynomial function. So that should have been what? Ax plus b. So that will be our approach. So that should have been ax plus b. Okay? So after you find that, you need to go with what? You need to find your y prime, y double prime, y triple prime. Let's go at it. So our y prime is going to give us what? It's going to give us the derivative of that will give us what? A only, because the b is going to be 0 because that's a constant. And then our y double prime will give us 0. Our y triple prime will give us what? Also a 0. Okay? After we give us, this one 0, that one 0. So what do we do next? What do we do next is to take now our original equation and substitute all these in there. So what would we get? Y triple prime, which is a 0, plus 3 times y double prime, which is also 0, minus 10 times y prime, which is what? A. Okay? This is equal to x minus 3. All right? So we're solving for A and B. Those are the parameters that we're working with. Okay? So those are the ones that we're working with. So these two 0, and this one is negative 10a equals to x minus 3. Now, as we're solving for a, in this case, there's no even b. How can we solve for a here? Because we're looking for a value, a constant, a number. But can we get a number out of this one? No. So this one can never be equal to x minus 3. So negative 10a cannot be equal to x minus 3. So we have a contradiction here. Because we have a contradiction here, we go with resonance. That means we are in resonance. Okay, so contradiction, so we are in resonance. So because we're in resonance, so that means what? That means we're now going to use another approach. And which one can we use now? So we're going to up now our initial approach. So instead of power 1, we go with power 2. That's what all it means. So that'll be y sub p then is equal to, so we have ax squared plus bx plus c. Okay? So that's how we go up. Okay? So from power 1 to power 2. All right? And then, again, we got to find out y sub p prime. And our y sub p prime will give us what? That gives us 2ax plus b. Okay? And then y double prime, it's going to give us what? It's going to give us 2a. And then the triple prime will give us what? 0. Okay, so those are the three that we have. So now we go back to our original equation again and substitute back in. All right, you see how it works? Okay, so now y triple prime, which is 0, plus 3 times y double prime. So the y double prime, which is 2a, minus 10 times y prime, which is 2ax plus b. And then that should be equal to what? X minus 3. Okay? So then, let's go at it. So we have 3 times 2 is 6a minus 20ax minus 10b equals to x minus 3. So what are we solving for in this case? What are the parameters that we have here to solve for? So we have a and b. There's no c. Okay? So a and b, what can we do? By analogy, so this one, we can equate those two. So that means what? That gives us what? Negative 20a. So we can drop the x's. So if we drop the x for this one, what is in front of it equals to 1, because that's invisible 1 in front of x. So we drop the x, this is what we have. So a is then equal to negative 1 over 20. So we have a, which is negative 1 over 20. We got to find b. So to get b, we go back here again in this equation and then equate it again. So we have this should be equal to negative 3, which is the constant. So we have 6a minus 10b equals to x minus 3. That's all we have to solve for. And then in this case, we're looking for b because we already know a. So it's 6 times negative 1 over 20 minus 10b equals to x minus 3. Are we good so far? All right. So then we can simplify. 2 goes into these two evenly. So 3 times here and 10 here. So you end up with negative 3 over 10 minus 10b equals to, so this is just 3, negative 3, okay? This is just negative 3. Careful, all right? So negative 3, and then what happens is, so we have negative 10, b equals to negative 3 plus 3 over 10. So you got to be careful when you're solving for these problems. So solving for b, so that will give us what? So this one from b is going then to b. So now this one, what do we do here? Lowest common denominator is 10. 10 times 3 is negative 30. Negative 30 plus 3 is negative 27 over 10. So negative 27 over 10. So let's just do this, negative 10 here. So negative 27 over 10. So that means b is going to be equal to what? B is going to be equal to positive 27 over 100. Okay, so we know A, we know B. So our y sub p, okay, we can just substitute it in here. And without even doing that, we can just go now and then add the 2 of these, right? So that means y equals to y sub h, which is what? C1. So that'll be C1, which is, so C1 plus C2 exponential negative 5x plus C3 exponential 2x. And then we're going to add the y sub p. So y sub p, this is what you're using, okay? So that means ax squared. So what is a? Negative 1 over 10. So that's negative 1 over 20, x squared. All right? Plus bx. And then the b is what? Plus 27 over 100 over x. Okay? And then plus c, we just said that c equals to 0. And this is going to be your final answer, ladies and gentlemen. Okay? So this is not that bad. Go back, take one step at a time, and then get it done. You'll be fine. Okay?